7.5 Algebraically defined vectors and the dot product. So, algebraic interpretation of vectors. A vector with its initial point at the origin is called a position vector. A position vector u with endpoint at point AB is written AB. The numbers of AB are horizontal component and vertical component respectively of vector u. The positive angle between the x-axis and the positive vector is the direction angle for the vector. Magnitude and direction angle of a vector AB. The magnitude length of vector u equals ab and is given by the absolute value of u equals a squared plus b squared, the square root of that. The direction angle satisfies tangent theta equals b over a can never be 0. So let's find the magnitude and direction angle. The magnitude and direction angle of u, 3, negative 2. So for magnitude, it's a formula. The absolute value of u equals the square root of a squared plus b squared. And where do we get our a and b? That's our a, that's our b. A is 3, b is negative 2. So let's plug it in. We have the square root of 3 squared plus negative 2 squared. So we get 9 plus 4. So our magnitude is the square root of 13. For our direction angle, it always satisfies tangent theta equals b over a. So we have tangent theta equals negative 2 over 3. We have to get theta by itself, so we inverse tangent. So inverse of tangent, negative 2 over 3. That is approximately, in degree mode, negative 33.7. Now we have to find the coterminal angle to that, so we're going to add 360. And we get theta is approximately 326.3 degrees. Horizontal and vertical components. The horizontal and vertical components respectively of a vector u having magnitude absolute value of u and direction angle theta are given by a equals u cosine theta and b equals u sine theta. U equals AB, it's the same thing as absolute value of cosine theta, absolute value of u sine theta. So it's x and y, that's why cosine is x, sine is y. So let's find horizontal and vertical components. We have vector w has magnitude 25.0 and a direction angle of 41.7 degrees. Find the horizontal and vertical components. So to find a, it's the absolute value of u, or whatever force you're working with, cosine theta. So we're given a force of 25 with an angle of 41.7. Let's find this distance right here. So we have a equals the force of 25 cosine theta. Our theta is 41.7 degrees, so we plug that into our calculator and you get about 18.7. We rounded to 3 significant digits because that's what we were given. Now for b, it's the same thing. We have absolute value of the force, sine 41.7, and we get b is approximately 16.6. So our AB is 18.7 and 16.6. That's our vertical and horizontal component. Writing vectors in AB form. So we have 3 vectors here and we're gonna write them in the form of AB. So the first vector we have is u. So u, it's 60 degrees. When it opens, it's 60 degrees. So we can find it by doing our absolute value of the force, cosine theta, absolute value of the force, sine theta. So our force is 5. Our angle is 60. Now, these two numbers, sine and cosine 60, first of all, 60 degrees is on the unit circle. Since it's on the unit circle, we use the unit circle. So, we have 5 cosine 60 is 1/2. Then we have 5 sine 60 is square root of 3 over 2. We simplify from here to get 5 over 2 and 5 square root of 3 over 2. Alright, our next one is red. Right here it's red, and the angle it makes is 180 degrees. So we have V equals, now to get our A and B, it's the absolute value of V cosine theta, absolute value of V sine theta. So the force for V is 2. So we have the absolute value of 2 cosine 180, the absolute value of 2 sine 180. Now, sine 180, cosine 180, those are on the unit circle. Since they're on the unit circle, we're going to use those values. So we have 2 times cosine 180, which is -1, and then 2 times sine 180, which is 0. So 2 times -1 is -2. 2 times 0 is 0. Now, it makes sense that it's 0 because that vector is not up and down anything. It's perfectly on the y-axis. That's why our y value is 0. Alright, moving on to the green one, W. So, the same rules apply. We find our A and B. So we have the absolute value of W cosine theta, the absolute value of W sine theta, and the theta that goes along with it is 280 degrees. The force is 6. So we have absolute value of 6 cosine 280, absolute value of 6 sine 280. Now 280 is not on the unit circle. Since it's not on the unit circle, we use our calculator. So when you plug it in, 6 cosine 280 is 1.0419. 6 times sine 280 is -5.9088. Vector operations. Let A, B, C, D, and K represent real numbers. A, B plus CD is the same thing as A plus C, B plus D. First goes with first, second goes with second. K times AB is the same thing as K times A, K times B. We distribute. If U equals A1, A2, then negative U equals negative A1, negative A2. AB minus CD is the same thing as AB plus negative CD, that is A minus C, B minus D. So we're going to perform vector operations. We have U is -2, 1, V is 4, 3. Let's find U plus V. So U is represented by -2, 1. V is represented by 4, 3. So when we add them, it's always first goes with first. So we have -2 plus 4, and then 1 plus 3. It's A plus A, B plus B. So let's simplify. We get 2, 4. And that is U plus V. That's if we added these two vectors. If we added them, this is where it would end up. Alright, part B, we have -2U. So we have, do what it's telling you exactly on the page. -2 times, because that's what touching means, times U. U is represented by -2, 1. So we distribute, we get -4, -2. So -2U is -4, -2. So this is if we wanted to double the vector and negate it. Alrighty, part C, we have 2U minus 2V. So the first thing we need to do is find each of those values. So let's find 2U. So it's 2 times U. U is represented by -2. 1. We're going to distribute. So we get 2u equals -4, +2. Now we have to find 2v. So 2v stands for 2 times v. V is represented by 4, 3. So we distribute, and we get 2v to equal 8, 6. Now we need to subtract them. So now we need to find 2u minus 2v. So it's first with first, second with second. So A's goes with A's, B's goes with B's. So we have -4 minus 8. And then we have 2 minus 6. We simplify to get -12, -4. And here are representations of each. So this is u plus v, this is just u, this is v. I only gave you representation of u plus v. So this is if we had, it's part A, these two vectors, and we added them together. If we add them together, it results in the red one, u plus v. Dot product. The dot product of two vectors u, a, b, v, c, d is denoted u dot v. That's read by dot. And it's given by the following. U dot v is the same thing as ac plus bd. So let's find the dot product of each. So we want to find the dot product, which stands for u dot v. So u dot v, we multiply a, b, c, d. So this is a, b, c, d. So it goes first with first, second with second. So a times c, b times d, and we add them together. But if you just remember, it's the same thing as part A of this example. So our first ones, we have 2 and 4. And then we're going to add that to b and d. B is 3, d is -1. And we simplify. 2 times 4 is 8. 3 times -1 is -3. So u dot v equals 5. All right, let's do it again. So we have our a, b, c, d. Now let's find our u dot v. So u dot v means we multiply the first two, add them to the second two. So our first two are 6 and -2. Then we're going to add that to our second two, which are 4 and 3. So we get -12 plus 12, which is 0. Properties of dot product. For all vectors u, v, and w, and real numbers k, the following hold. So u dot v is the same thing as v dot u. U dot v plus w is the same thing as u dot v plus u dot w, because you distribute. U plus v dot w is the same thing as u dot w, v dot w. Ku dot v is the same thing as k times u dot v, and it's the same thing as u dot kv. 0 dot u is always 0, and u dot u is always absolute value of u squared. So same rules apply to like normal equations. Geometric interpretation of the dot product. If theta is the angle between the two non-zero vectors u and v, where your theta is between 0 and 180, the following holds. Cosine theta equals u dot v over absolute value of u, absolute value of v. So this comes back to example 1. So that's how we're going to find our u and v in our denominator. We use formulas of the square root of a squared plus b squared and c squared plus d squared. So let's find the dot product. Let's find the angle theta between two vectors. So to find the angle, it's a formula, cosine theta equals u dot v over uv. So u dot v, that's the same thing as we're going to multiply them together. And then our denominators, we have to use those formulas. So at first, let's do the dot product. So it's first with first. So the first one in u is 3. The first one in v is 2. Then we're going to add that to our second ones, which are 4 and 1. And then our denominator, we have u and v, so that's the formulas that I listed to the right. So for u, it's the square root of a plus b squared. So we have a, which is 3, b, which is 4, and then you're going to multiply that to the same thing, but with c and d. So our c and d, it's the square root of c squared, which is 2 squared, and then d squared, which is 1 squared. And from here we simplify. So on the top we get 6 plus 4. On the bottom we get 3 squared is 9. 4 squared is 16. 16 plus 9 is 25. 2 squared is 4. 1 squared is 1. 4 plus 1 is 5. We keep simplifying. So now we have cosine theta equals 10 over 5 times the square root of 5. Now, we're not trying to solve here, like we're not trying to simplify 10 over 5 times the square root of 5. We're trying to find the cosine. We're trying to find theta. So we don't need to simplify our fraction. From here, we know to find theta, we're going to inverse cosine of 10 over 5 square root of 5. So you plug that into your calculator, and you should get about 26.57 degrees. Alright, let's do the dot product again, or the angle between two vectors again. So the formula is cosine theta equals u dot v over u v. Alright, so for u dot v, it's always first, second with second. So our first one, we get 2 times 6 plus negative 6 times 2. And in the denominator, we do our little thing that we did up here. So for our first one, it's a squared plus b squared, so 2 squared plus negative 6 squared. And then we're going to multiply that to the v, which is c squared plus d squared, so 6 squared plus 2 squared. And we simplify. So we have cosine theta equals 12 minus 12 over, so 2 squared is 4, 6 squared, negative 6 squared is 36, 36 plus 4 is 40, 6 squared is 36, 36 plus 2 squared, that's 40. We're left with cosine theta equals 0 over, well, these two are the same. When they're matching, it just cancels out, so we're left with 40. 0 over 40, that's just 0. So we have cosine theta equals 0. We take inverse, you should know that, it's 90 degrees, but it's okay if you don't. We take our inverse cosine. So inverse cosine of 0, and we get theta equals 90 degrees. If your u dot v is 0 for two non-zero vectors and u and v then cosine theta equals 0. Theta is 90 degrees, thus u and v are perpendicular or orthogonal vectors. So just like we got here, what this means is if we had these two vectors, they're perpendicular. They're perpendicular from one each other because they create a 90-degree angle.